Now I haven't walked through this one yet, but it has the potential to get interesting, finding the direction angle of a vector. So most of these I'm going to be switching over to drawing, but this is the vector W, component form is 4, 0. And that's something you can graph pretty easy, and you should graph it. Got our I and J axis, and I'm going to go right 4 and up nothing. Now it's talking about the angle, all right? The angle is always formed with the x-axis. And there is no angle with the x-axis, so the angle on this one is 0 degrees. All this thing does is run right 4. It doesn't do anything else. It doesn't rise or fall. Brilliant. This one is going to fall 5. All right? So let me draw that out for you. I'll switch over after I get it drawn. So it falls 5 units. This is a rotation, a clockwise rotation. And how are we going to, sorry, it would be a negative 90-degree rotation. They might also accept a positive 270. I don't know if you remember those lessons or not from Algebra 2 or not. But I'm going to see which one it takes. I'm going to throw in 270 because I like positive numbers. It should be smart enough to figure it out. And it was. Good. Wonderful. So I'm just going to keep angles positive as long as I can. This is 0, negative 8. Same thing. All it does is fall 8, 270 again. 0, negative 6, also 270. All right, finally something different. Negative 4i minus 9j. Get that graphed. This particular guy goes back 4 and then falls 9. That's what it does. It ends up right here. All the way down there. So the classical way of doing this is to triangle it out. All right. Put theta prime in a corner. Theta prime is what we call a reference angle. And we were back 4 and down 9. So these lengths that I have are the adjacent and opposite. Okay, this is adjacent and this is opposite. Hopefully you don't have an issue with that. I go through my trig ratio, SOHCAHTOA, and I focus on tangent. I know that the tangent of theta prime is negative 9 over negative 4, which is 9/4. So the tangent of theta prime is 9/4. If the tangent of theta prime is 9/4, then theta prime is the arc tangent of 9/4. Almost all of these use that. So the arc tangent of 9/4 has to be done. Now there's a reason I'm drawing here, because if I just push buttons in a calculator, I don't see the whole picture. Make sure I'm in degree mode here. I'm in radians, got to be in degrees. This thing is talking about nearest tenth of a degree. So I go over to my TID4, I do the arc tangent of 9/4, and I get that the reference angle is 66.04 degrees. All right. Now, what I had to do is I had to rotate half a circle, 180 degrees, and then another 66.4. So 180 plus 66.04. And they want this to the nearest tenth of a degree, so 246.04. If they're rounding right, which I hope they are, I'll have to type in 246.0 degrees. Otherwise, they're probably kind of wrong. They tell you to round to the nearest tenth, you need to show the nearest tenth. So 246.0 degrees. Correct. All right, here's one. This one, if you think about it, you're rising. So you're rotating 90 degrees. We got another one of these. There actually is a shortcut to these. There's a formula for it. I don't know if you were paying attention, but I'll write it down on this one. But the thing is, you have to still think about your rotation and what you're doing, okay? But there is a formula for this. It's actually pretty simple. Theta is, the tangent of theta is j over I. That's what it is. It's always that way. So this one's going to be 3 over -2. So the arctangent of -3/2 will yield the angle theta prime. That should say theta prime, because depending on what this answer is, I might not want to use it. I might have to manipulate it. And this is going to be something that has to be manipulated because, well, actually, is it? Arctangent is defined in quadrants 1 and 4, so yes, this will have to be manipulated. The arctangent of -3/2 is -56.31 degrees. And IXL should reject that because that's not correct. When you plot the original coordinates, you would go back 2 and rise 3, which would put you right there. If you could see what I was drawing, it would put you right there. There's your vector. Turns out that this is actually 56.31 degrees. Calculator lies sometimes. I'm sorry. So what did you do? That's the real question. What's the actual positive rotation? This is the actual positive rotation. It's going to be 180 minus 56.31 degrees. And I know that's going to get some kids, and I'm sorry it does. It's just the way things are. What do we need? 23.7 to get to 80? So 123.7 degrees should be my answer. It's actually 123.69, but they want you to round the nearest tenth. 123.7 degrees. Seven J. So 7J is going to go straight up. 90. 8I is going to go straight right. No rotation. 4I plus 8J. That's going to be in quadrant 1, which is kind of nice. I like angles in quadrant 1 because when angles are in quadrant 1, you can always trust what your TI-84 says. Always. This is 4I plus 8J. To the right 4. I was kind of hoping they would use some special triangles in here, but they haven't. That's what the vector looks like. So think about your triangle. 4, 8, it's in quadrant 1. You can trust whatever your TI-84 tells you to. But this would be, again, that the arctangent of 8/4, or 2, whichever number you want to use, is theta. And whatever the calculator spits back on this thing, you can trust. Arctangent of 2, 63.4 degrees. I'm going to level up because I'm sure you're tired of watching me. Oh, there is no other level. Okay, so since there's no other level, this is as hard as they get. So U3 needs to be taken to an 80, and you will have seen hopefully everything you need in U3. One would hope.